Hey, it's Chuck from Conduktor, and today we're going to look at how to deploy Conduktor Gateway on Kubernetes. Conduktor Gateway is a Kafka protocol-aware proxy. It sits between your Kafka clients and your Kafka brokers. It's able to intercept requests from clients or responses from brokers and modify them in various ways. There's a collection of dozens of interceptor plugins that allow you to implement various functionality. And these plugins or interceptors are managed via an admin API. Let's take a look at some of these interceptors. Here's our interceptor catalog, broken down into a few different categories. I'll point out just a couple of the things you can do. For data quality, there's a schema payload validation interceptor. When you create this interceptor, Gateway will inspect each record and make sure that it adheres to the schema it's supposed to. And on top of this, you can also do business rule validation as well. The interceptor configuration is defined in JSON. Here's an example. You specify the plugin class and provide necessary configuration, and now Gateway will enforce this rule centrally. Another interesting interceptors are encryption and decryption interceptors. This allows you to do field level encryption on produce and field level decryption on consume. I encourage you to try these and the dozens of other interceptors that Gateway offers. But let's get to deployment. The default way Conduktor Gateway routes traffic to Kafka brokers is with port-based routing. Each Gateway instance opens up a port for each broker. And here we also see a port open for the admin REST API. However, this can cause complications when the number of brokers changes. Gateway is happy to automatically expose more ports, but firewalls and load balancer targets would require reconfiguration. This is especially problematic when using a managed Kafka service, where the number of brokers can change without warning. One way to solve this is with host-based routing, also known as server name indication or SNI routing. SNI routing allows Gateway to expose a single port and route requests to individual brokers based on host name rather than port. Let's take a look. This tutorial sets up SNI routing specifically for a Kubernetes cluster that exposes Gateway to clients externally via an ingress. Kubernetes has its own networking concepts, so it's helpful to see an example for how SNI routing works for Conduktor Gateway deployed on Kubernetes specifically. Here's an overview of what we'll deploy. This tutorial uses OrbStack on Mac, specifically so that we can showcase how external routing works through an ingress. For the sake of keeping everything local and not running up your cloud bill, I'll use OrbStack. And this is Mac only, so sorry about that. For Kafka, we're going to use the Bitnami Kafka Helm chart to deploy a couple of brokers. They'll be accessible via an internal service. For Gateway, we're going to deploy a couple of Gateway replicas in an external service. And we're going to expose that external service via an ingress. To get a sense for how this works, let's consider a request coming from the client and follow that request through the stack. Let's suppose the client is trying to make a produce request. So first it needs to know which broker is the leader for the partition it wants to produce to. It's going to make an initial connection using its Bootstrap server. It's going to receive some metadata that tells it which broker it needs to connect to directly. So here, the Bootstrap server is gateway.k8s.orb.local. So the client will connect through the ingress to the gateway service, and it will receive a response that tells it which broker to connect to. Let's suppose broker 1 is the leader for this particular partition. Gateway will respond telling the client to use broker main1.gateway.k8s.orb.local to reach that broker. It's important that this host resolves to the IP address of the load balancer. So now the client makes a request to broker main1.gateway.k8s.orb.local. That goes to the ingress controller, which passes through to the gateway, and Gateway uses that broker main1 to understand that this request needs to be forwarded to the broker with ID 1. And that is how host-based routing works. There are three important things that get this to work. First is the subject alternate name of Gateway. So here we use a wildcard name, star.gateway.k8s.orb.local. And this allows the client to trust Gateway when it presents as a specific Kafka broker. Another important piece is TLS pass-through. TLS needs to go all the way through to the gateway so that gateway can use those SNI headers to route the request to the correct broker. And finally, the client needs to be able to resolve all of these host names to the load balancer being used. So here we have gateway.kates.orb.local. It resolves to the ingress IP. And then also we would need a wildcard CNAME alias so that all of these host names are routed to the same load balancer. All right, let's get hands-on and see how it actually works to set this up. All right, let's get going with the deployment. Here I'm running on Mac using Brew. Install a couple of tools. Helm, we're going to be using some Kubernetes Helm charts. OrbStack, that's the Kubernetes local installation that does this networking magic that we need. OpenSSL for some certificate things. JDK to run key tool and some Kafka commands, Kafka and the Conduktor CLI, so we can install those things and get going. Let's go ahead and prepare certificates. We'll generate what we need for TLS, and you see a bunch of things are being populated in the certs directory. Specifically, we have a certificate authority. Here it's called Snake Oil. We use that certificate authority to create a couple of different certificates. One for Kafka, one for Gateway, and we also have a trust store that trusts certificates signed by the certificate authority. Let's inspect the Gateway certificate. We see the issuer, which was the certificate authority. We see the subject, which is Gateway. And specifically, we want to look at the subject alternative names that we've given. So the key point here is we want the client to trust this certificate when it comes from any of these host names. And in particular, what's important here is we have the external host name, gateway.kates.orb.local. We also have this wildcard SAN, star.gateway.kates.orb.local. And that's what's going to allow the client to trust Gateway when it presents as either this host name or any of the specific broker host names. Okay, we have our certificates in place, and now we will deploy some of these services. We're going to run the start script to deploy this, and then we'll break down what's happening in there. So I'll run this and open up the start script. You can even close this. So first we start local Kubernetes with Orb. We create a namespace. Orb will automatically configure kubectl to connect to this Kubernetes cluster. So here we're going to be creating some secrets for Kafka. We've got key store passwords, client passwords, Kafka certificate. So it's going to need both a key store for its own certificate and then a trust store to trust the certificate from other brokers for interbroker communication and for client broker communication. Then we're going to create some secrets for Gateway. Again, key store and trust store. So it's going to need a key store to present its certificate to clients. It's going to need a trust store to trust Kafka as it connects to Kafka. And we have some secret configuration variables here. SASL-JAS config. We've got gateway, key store password, key password, HTTPS. So this is for the admin REST API as well. We're going to need a key store. We're going to use the same key store for that. And as well as the Kafka trust store password when we're connecting to Kafka. Then we'll install components. We're going to use Helm to install Kafka from the Bitnami Kafka Helm chart. We'll add a couple of repos. Then we'll install Gateway using the Conduktor Gateway Helm chart. We're going to install the ingress controller. We'll be using ingress nginx. And notice here, very important, that we have to set enable SSL pass-through to true. We're going to create an ingress. We'll take a look at that in a moment. We do have to patch a couple of things In the Conduktor Gateway Helm deployment, because we are using HTTPS for the admin API, we'll have to specify HTTPS for the liveness and startup probes. This is one of a handful of small pointy edges to the Conduktor Gateway Helm chart, which is actively being revamped. So hopefully by the time you see this, you won't have to do this. All right, let's take a look at the ingress that we create. So we have a couple of important annotations for Nginx ingress. We need SSL pass-through to true, SSL redirect to false. This is a little bit of a misnomer because what we're really specifying here is that we're using TLS. All of this protocol is happening at the TCP layer, layer 4, not layer 7 with HTTP. Nevertheless, we do need to put this annotation so that we're using TLS. Inside the spec, we have the ingress class name, which is Nginx. We're going to specify TLS hosts. So here we have the bootstrap host here, which is gateway.k8s.org.local, and then also a wildcard host, star.gateway.k8s.org.local for each of the brokers, and some rules. So for that bootstrap endpoint, we want this to route to the backend service called Gateway External. That's the external service that we create with the Helm chart. And for these specific paths, we have Gateway v2 and we have admin. We're going to route those to port 8888 HTTPS. So this is the admin REST API. And for that second host, which is this wildcard, we want to send those to Gateway External as well for our service. All right, so let's pop over to the Gateway Helm chart. So under Helm, we've got gatewayvalues.yaml. There are a couple things to point out. We recommend deploying with multiple replicas, and that's because Gateway is a stateless proxy that can be horizontally scaled, and we want it highly available and scalable. We have several configuration environment variables that are being loaded via secrets, one of the secrets that we created earlier. We've broken the configuration down here, connection to Kafka, that's connection between Gateway and Kafka versus the connection between client and Gateway. The connection between Gateway and Kafka is like any connection between a Kafka client and Kafka brokers. So here we specify the SASL mechanism, the protocol, where the trust store is, and the SASL-JAS config is provided through that secret we created earlier. There's a couple of nuances to talk about in the client to gateway connection. So the first here is that we're using delegated SASL SSL. And what that means is basically Gateway will take whatever credentials the client gives it and forward it on to Kafka for authentication. So here we're not separating authentication client to gateway and then gateway to client. We're actually doing sort of a delegated authentication where the credentials go all the way through to Kafka. Since we're using host-based routing, we need to set that we're using this gateway routing mechanism host, and the SNI port we're using is 9092 in this case. And the host separator, this is important. Here we're going to be using a period, and how this will show up is later the host name for each broker will be broker main 0.gateway.k8s.org.local or broker main 1. Broker main 2. etc. So that separator is the dot. It's often easier to do wildcard SANs and wildcard DNS if you don't use a dot for the hostname separator, in which case you would use maybe a dash, and that would look like broker main 0 dash gateway or broker main 1 dash gateway. Same sort of thing. Here I've chosen to use dot. Here, since we're using Kubernetes and it has its own load balancing services, we're going to disable the internal load balancing that Gateway does. Basically, this just means that we're trusting the Kubernetes load balancer to effectively distribute load across the Gateway replicas. For the port range section, again, we're using SNI routing, so we only need one port. So we're going to start at 9092 and just need a single port. For the trust store, one of the sharp edges of the Helm chart today is it requires a separate volume mount for the trust store. The TLS configuration, which we see down here, it has configurations available for key stores but not trust stores. So for the trust store, have to do a separate volume mount to mount that trust store, which is fine. And we are exposing this service externally. So here we enable the external service. We make sure that it is a type load balancer, and make sure that we also expose the admin REST API through this external service as well. Okay, so let's test this deployment. So first, let's try to connect to the REST API. Here we're going to trust the snake oil certificate authority. We're going to hit that external endpoint at port 8888. Use the default user and password for that admin REST API. And we get nothing, which is good. It was not an error. The REST API, it is just a REST API, so we can use curl as well. And we get a list of empty interceptors because we haven't created any interceptors yet. So it looks like connectivity via the admin REST API works. Let's look at Kafka. So in newer JDKs, we have to specify this option to allow the security manager. You can see that KIP for more details. But let's take a look at some of the metadata that's returned. Let's go directly to Kafka. So I'm going to use this Kafka CLI tool to look at the metadata. And notice that I'm connecting to the internal Kafka Bootstrap. Normally this wouldn't work. You'd need to run this command inside of your Kubernetes cluster. But it works here because Orb does this neat little magic trick where you can actually access internal services from your host without having to first be inside of the Kubernetes cluster. So let's go ahead and get that metadata from Kafka directly. Lots of output, but what we basically want to see is we have specific broker IDs, and they have specific internal service names. Franz Kafka Controller 2, Franz Kafka Controller Headless, etc. So we will see Franz Kafka Controller 2, Franz Kafka Controller 1, and Franz Kafka Controller 0. Those are our three brokers. And now let's do exactly the same thing, except we're going to connect to Gateway externally through the ingress and see what it returns to us. Similar thing, but we have for broker 1, we have broker main 1.gateway.k8s.orb.local. We have broker main 0, and we have broker main 2. So that all looks in order. All right, let's create a topic going through Gateway from external. Create a topic test. Let's list topics, this time from Kafka directly, internally. We see all of our Gateway internal topics as well as tests that we just created. We could do the same thing going through Gateway instead. We can produce the topic going through Gateway. And let's consume from the topic, also going through Gateway. There it is, and I'll Control C to exit. And there it is. So we can go ahead and clean up. And for our takeaways, a couple of important points here. So first, your ingress controller must support layer 4 routing. That's TCP, not HTTP. And it must do so with TLS pass-through. For AWS EKS, that would mean using the load balancer controller with a network load balancer not an application load balancer. And TLS pass-through is required so that Gateway can use those SNI headers in the TLS handshake to route those requests to specific brokers based on the host name. Second, your client must be able to resolve all hosts advertised by Gateway to the external load balancer. In this example, OrbStack magically points all of these hosts to the Ingress Nginx ingress controller. And in the ingress, we defined all of these to point to the Gateway external service. So here we have the Bootstrap endpoint, and we have hosts for each broker. And a key thing here is if brokers are added or removed, with the way that we've defined the wildcard SANs and the wildcard DNS, clients will be able to resolve and connect to any broker, regardless of if somebody adds a broker and doesn't tell you, it'll still be routed correctly, and certificates and connectivity will remain intact. Next, the Gateway's TLS certificates must include those SANs, so it can be trusted by the client when it presents itself as different brokers. Wildcard SAN is easiest. In this example, it's this. Since we're using an external load balancer, we do not need to use Gateway's internal load balancing mechanism. The external load balancer will distribute load, so that's what we saw earlier. Thanks for joining today, and wish you luck as you deploy Gateway with SNI routing.